Okay, so far we've looked at a couple of examples of how to solve a system of equations using substitution, and now I just want to give a little bit of a note structure to this whole thing. So we're going to do one kind of example with the structure of this is what you should look for every time, and then we'll do maybe 3 more quick examples at the bottom so you have a few things to work from before you do some practice on your own. So for a substitution, every time you have to make sure that one of the variables, either the x or the y or any other letter that you're using, is by itself on one side of the equal sign, right? In at least one of the equations. So, right, in that first example, the race example that we did, they were both by themselves. The y's were kind of all alone. It was y equals 7x and y equals 4.5x plus 40. So I could then take this, like what is y? It's 7x. Replace y with 7x in the other one. Right? In the second example we did, that dinner example, it wasn't quite so cut and dried. We had, right, there was no thing by itself in either one of the equations. So what we had to do was a little bit of work to get this y by itself by moving the x to the other side of the equation. We subtracted x from both sides of this first equation to get a new equation, y equals 18 minus x, that we could then put in. Right. So that's what you have to do every time, is make sure, right, if you have 2y here, it doesn't count. It has to be just y. If you have a 2y, divide both sides by 2 to get it so that it's all by itself. And if that's the case, there's probably a different, easier example or a different method that we will learn later. So I have here the y by itself. So the second step is that in the other equation, in the second equation here, replace that variable. So I have y by itself. So I'm going to find y in the second equation, and I'm going to replace it with whatever was on the other side of the equal sign. Right? This is an expression, 30 minus 2x. Since y is equal to that, they are the same thing. Where I see y here, I can take the thing that y is equal to and replace that y with it. Right? So in that second equation, I had 3x plus 4y. Equals 70. Well, I'm going to replace the y in that second equation with what y is equal to, 30 minus 2x, right? So I take that 30 minus 2x, put it in place of y, and now I have one equation with only one unknown. The x is the only thing that's in there. The y is gone, right? So now back to, again, the solving just regular one equation for one unknown. It's a little bit more complicated than the 2 examples that we just did, because I have 4 times y. Y is all of this. So I need to do 4 times 30 and 4 times negative 2x, or minus 4 times 2x. So we do the distributive property, bring that 4 times the 30 and the 4 times the negative 2x. 4 times 30 is 120. 4 times negative 2x, or negative 4 times 2x, is negative 8x. Right, so I actually multiply those things through. I can combine my like terms. I have 3x's and negative 8x's. When I put those all together, I have negative 5x's. 3 minus 8 is negative 5. Get rid of the 120 on this side by subtracting both sides of the equal sign by 120. That goes away, and I'm left with negative 5x equals negative 50. And divide both sides by negative 5 to get x equals 10. So that's kind of all step 2. Replace it, then solve for that first unknown quantity that we're trying to find. Right? The next thing we have to do, right, because this, a lot of people try to think that they are done at this point, is like, I got x is 10, sweet, we're done, I found x. But it's not really the solution to the system, right? That is half of the solution, right? What we need to do is find the other half. What's the other variable? So I could use either one of these equations that I'm given. I have 2 different equations, right? I'm going to use the easy one. I changed my numbers after a little bit to make it, right? This should be 70 the whole way through. Right? I'm going to pick the easier one, right? This one has got a 3x and a 4y, and I could put in 10 here and solve, but I'm just going to do the one where it's like y equals this. So I put the 10 in for x there. Just take this 10 right in for that. 2 times 10 is 20. 30 minus 20 is 10. Y in this case is also 10. Right? So with that, now I have my solution to the system. Right? My solution is x is 10 and y is 10, so it's the point 10 comma 10. I want to check this, right? Like a good habit of practice is, right, I used the first equation to find it, so it better be true in the second equation. So the last thing that you should do is check those numbers and make sure that they work for the other equation as well. So the second equation was 3x plus 4y is 70. If I put in 10 for both of those things, is it equal to 70? Yes. So I can be confident in my answer. I have the solution to that system is 10 comma 10. So let's do a few more quick examples here. I'm going to do another example. I have x plus 2y equals 11 and 5y minus x equals 10. Okay, again, going step by step. First step, make sure one variable is by itself. That is not the case here. I don't have anything all by itself. So I want to try to do something, right, to get a variable by itself, either the x or the y. So I see in this first equation, there's only one thing I would need to do to get x be by itself. Right? If I take that, I have x plus 2y equals 11. Well, let's subtract 2y from both sides, so that this kind of becomes a zero pair and goes away. So in the first equation then, I would have x equals 11 minus 2y, right? So I'm just going to rewrite. It's still the same equation. I just rearranged it a little bit. In the next one, I have 5y minus x equals 10. But now I've achieved what I need to at the first step. I have a variable by itself. So now I can take this 11 minus 2y and I can replace the x in the second equation with that quantity. Right? I'm going to put in x is 11 minus 2y. So in the second equation down here, I'm going to have, do a little line there, I have 5y minus that whole thing. 11 minus 2y equals 10. All right. So, and replace what x is equal to, like replace the x with that. So I'm subtracting both of these here. So I'm going to have to like distribute this negative sign through. So I'm going to have 5y minus 11 and then minus negative 2y. Right? That minus negative 2y equals 10. I'm going to rewrite that double negative as a plus. Right? Plus 2y equals 10. Yeah, again, back up this first equation here. Right? Once I do that substitution, now I have one equation with only one unknown that I'm going to solve, just like we did with the last one. Right? So now I'm going to combine my like terms. I have 5y and 2y on the same side of the equal sign, so that makes 7y total there. I have to get rid of the 11, so I'm going to add 11 to both sides of the equation. You can write it in line, kind of like we did up here, or sometimes you can just do it underneath. I'm going to do that for these just for speed's sake here, right? Because that is going to cancel. I have 7y equals 10 plus 11 is 21, and divide both sides by 7. I get y equals 3. Okay, halfway done. I found what y is, but I need to find what x is. So let's go to one of these original equations. Let's just go right here. I have x equals this, right? So I'm going to put y in for that, right? I have x equals 11 minus 2y was an equation that I started with. So I'm just going to replace the y with a 3. I have x equals 11 minus 2 times 3 is 6. So x equals 5. Y is 3, x is 5. I know it's going to work in the first equation, right? I have 5 plus 2 times 3 is 11. That's kind of what I used to find the x, but let's check it in the other one. Is 5y minus x equal to 10? Well, 5 times 3 minus x is 5. Is that equal to 10? 15 minus 5. Yes. Right. We're good. My solution is 5 comma 3. My x is 5, my y is 3. I found my y first this time, which is a little bit different than what we've done before. But I still, when I write the ordered pair, it's always x first, then y. Okay. All right, let's do another example here. Do switch colors. All right. Here we'll have x plus 3y equals 19. And 2x plus 4y equals 24. Again, going back to my first step, is something by itself? The answer to that is no. But in this first equation, again, the only thing I would need to do to get x by itself, let's just kind of rewrite this down below here, is if I subtracted 3y from both sides. That first equation, I have x plus 3y equals 19. Let's get the x by itself by subtracting 3y from both sides so that that goes away. All right. So then I have x equals 19 minus 3y. Okay, so now I have a system I can work with. 2x plus 4y equals 24. And I had x by itself. I chose the x instead of the y because that's just a one-step thing, and I won't need to worry about any fractions. If I try to get y by itself here, I have to subtract x, divide by 3. It's a lot more complicated than just moving that to the other side there. And now I have x is all this. So I'm going to replace this x here with that. I'm going to put 19 minus 3y in place of the x. So when I do that, I have 2 times x. So I need to do 2 times this whole thing, right? I need to replace the x with all of this. So I'm not replacing the 2x, right? 2x would be double this. 1x is that. So I need to do 2 times this plus 4y equals 24. Right? I'm only replacing the x with the thing that x is equal to. Right? And now I have one equation with y being the only thing that I don't know. So let's do some work. I have to distribute the 2 times the 19 and the 2 times the negative 3y. 2 times 19 plus 2 times negative 3y plus 4y equals 24. That I get 38 minus 6y plus 4y equals 24. This, I have a negative 6y and a positive 4y. Those are going to come together to make negative 2y total. So I have 38 minus 2y equals 24. I got to get rid of that 38, so let's subtract 38 from both sides of this equation here, using that subtraction property of equality, so that goes away. I have negative 2y equals 24 minus 38. You can grab a calculator for that if you want, but it's negative 14. And the last step is divide both things by negative 2. Again, remember, when you get rid of this, that negative doesn't go away too. That has to come along. And so when I divide, I have to divide by negative 2 here to get my final answer. Y is negative 14 divided by negative 2. I have the double negative there is going to make a positive 7. So I found my y. Now let's go back and find what x is. X using this equation here. X is 19 minus 3y. And let's just put that y, that 7 in for y, right? It's basically just another substitution. I'm just putting 7 back in for that. So I have x equals 19 minus 3 times 7. X equals 19 minus 21. X is in negative 2 in this case. Last thing I should do is check. Right, go back to the other equation that I didn't use, the 2x plus 4y is 24. And put in, I found that x was negative 2. That y is 7. So are these equal? Right. That would be negative 4 plus 28. Is that equal to 24? Yes. It is. We're good. My solution is negative 2 comma 7. All right. Let's stop there. Right. This is substitution in a nutshell, right? Just make sure, right, follow those steps up here, right? Get one variable by itself, plug it in. Sometimes you might need to distribute, like you have 4 times y, 4 times that variable you're plugging in. But yeah, good luck.